Welcome everyone. I'm Marcin Nowakowski from Gdańsk University of Technology. In this talk, I will present concepts of internal and external observers, which might be fundamental for future development of quantum gravity and quantum information theory. And I also would like to elaborate a bit about how those concepts can be applied to AI and consciousness models. Okay, so let's jump to the outline of this talk. I will start with some introduction about a central concept in quantum information theory and also in relativity theory, which is observability. Observability as such is naturally related to a concept of observers, and in particular to the newly introduced concept of an internal observer and external observers. Furthermore, I will also show you how those concepts are rooted in very solid mathematical systems. So I will talk about topology, a bit about topology, because we have a very limited time here in this talk. And then what is very interesting as regards the external observers, we naturally get to a hierarchy of observers and levels of reality which are perceived or built by the observers. We ask questions about how to ensure consistency of information processing by external observers and also by the internal observer. As regards the internal observers, I will show you the concept and the principle of self-reconciliation of information, which is rooted from the sheaf theory. As regards the internal observer, the principle introduced related to ensuring consistency of information processing is called a self-consistency principle. Further, I will also present you internal histories and how they are fundamentally related to consciousness and also to future models of artificial intelligence. In the end of this presentation, very briefly, I will mention about the future prospects. Let's elaborate now on the concept of observability. Observability as such is a central idea both in quantum mechanics and general and special relativity theory. Einstein's consideration of causality and the structure of space-time leads to a very interesting observation that space-time as such does not have a solid foundation without observers. And the foundations of his theory are events and connections among events. Einstein, in many papers, mentioned about the importance of the observer and also of the reference frames. As regards quantum mechanics, naturally we associate with an observer a set of quantum observables, which is very well formally defined by means of Hermitian operators. But quantum mechanics currently addresses the external states of an evolving physics object during the act of observation or interaction. But what is not fully understood is the internal evolution of the system. So, following Einstein's thought experiments, we could ask a question what it would be like to be or to see it inside a photon. So, just what would be like to be inside a photon, to take the perspectives of an observer, which is a system. To be more precise, an observer in general relativity can be defined as a world line in space-time, but the fundamental concept is to associate with an observer a reference frame, which is described by a collection of events, those aforementioned primitives of the theory that occur at the same place and time for the observer. And Einstein also in his fundamental papers mentioned about the importance of synchronicity and lack of synchronicity of observing an event. In natural way, each observer carries its own set of clocks and rulers to measure time and space respectively. And what is obviously very interesting and what you know is the relativity of time. So this is why with an observer in general relativity, one can associate a proper time, which is defined as depicted in this picture. In quantum mechanics, when we ask about an observer entity, we think about a quantum detector that measures quantum systems. So an observer actually is a kind of an external entity which is correlated with a system that will be measured. Measurement of an observable leads to entangling evolution. So this is what you can see under the state psi Ta with a state R of a register, which evolves to a new state when a measurement occurs. What is interesting is that one can ask what is an overall state of the evolution from time minus infinity up to time plus infinity. So the state here actually it's in a representation of a Page-Wooter state coming from Wheeler-DeWitt equation, where we consider actually kind of a frozen universe where the evolution is injected into the overall state. What is interesting is that in this case, we have a superposition over different time steps. But naturally, in quantum mechanics, for many years, we have a deep philosophical debate about the nature and the role of the observer, about the nature of influence of an observer on the evolving system. Recent theories consider quantum reference frames, naturally following the findings coming from relativity theory. But in this consideration, in some sense, we blur the distinction between observer and observed. Actually, observer and observed are part of the overall system. A big open question and debate is around, naturally, collapse of the wave function, and if the collapse actually is a real phenomenon or is a mathematical trick. To answer a question about the internal perspective of a physical system and how to represent an internal observer, I introduced the concept of internal and external observers. The internal observer is associated with the internal observable superalgebra, which actually glues the external interactions. I will come to this point in a couple of slides. Further drawing inspiration from the advancements in abstract algebraic topology, I propose mathematical representation of this internal observer. I also outline principles for ensuring the consistency of observers in terms of information theory. And what is interesting is that the analysis, as I mentioned, bring in some sense the hierarchy of observers, and it finds out that entanglement is a primitive of space-time causal relationships. To give some analogy, we can take a look at the Plato's cave, very famous one, where we have some picture projected on the wall, on the boundary. In terms of the observers, I would say that we have some internal reality which is being projected onto the boundary of the system. So we can give a simple analogy which is imperfect about comparison of quantum and classical systems, quantum and classical reality, where classical reality or classical probability distributions are actually projections coming from quantum level of reality. And so the internal observer reflects the internal reality or interior mathematically of a system O. And external observers, they reflect what can be observed on the boundary of the system by interaction with other systems. If a system does not interact, it cannot be observed, it cannot be measured, then it doesn't exist externally, although it exists internally. I'm giving here a nice picture, actually very well known from quantum mechanics, about multiple paths connecting two space-time point events, point event A and point event B, for a particle emitted at the point A and observed at point B. So they are connected naturally by potential paths. So it comes from famous Feynman consideration of his theory, and one can naturally associate some quantum phase with each and every path, and we can also associate a quantum history and some probability amplitude with each path. So the overall probability amplitude is a superposition for this quantum process, but the important point is that we have two boundary states. So we have some predefined and post-defined state here. So in the search for formal representation of internal and external observers, I turned to inspirations from abstract algebraic topology. And one of the key inspirations, which is very relevant to this symposium, is the concept of impossible topological objects, such as the famous Penrose-Treiber, which is here on the slide, or the Mobius strip. The internal observer can be associated with a global impossible object that locally, at different levels, gives possible objects, external observers, and the external observers remain part of the global internal observer. The key analogy relates to the difficulties observed in finding a consistent theory of quantum gravity, where local observations do not reflect the global aspects of reality. Another example of this quantum is quantum locality, naturally, which can be observed in space-time for entangled multipartite systems where local subsystems cannot detect that they are part of a global entangled state. And if measured, they would generate correct local distributions. But we also know that, based on the recent research, that the existence of quantum entanglement in both space and time seems to be more fundamental than space-time itself. Obviously, we can also talk about quantum entanglement in time. I also wrote some papers about that. However, even though measurement statistics are available for measurement results, we cannot directly access the internal reality of the system that connects these interaction points. And it's becoming clear, looking at the research which is being presented very briefly in this presentation, that classical quantum gravitational aspects of reality are the next levels of inherent hierarchy of observers and the realities, starting from some local purely classical through local quantum to more global and non-local levels of reality. And to formally represent internal and external observers, I'm covering the system, actually a physical system, with an abstract simplicial or combinatorial complex of observables. So it is as if we are doing a kind of a tomography of an internal reality or internal system by means of those tools. An internal observer is represented by quantum sheaves on simplicial complexes, where each stalk associated with a vertex represents the local reality of an external observer. So when we think, for instance, about consciousness, naturally we can try to associate with consciousness states of a mind some internal observer states. So this is the connection that I will also deep dive a bit in a couple of slides. So still being very abstract, but showing that the concepts are very, very well rooted in abstract algebraic topology, the internal observer is associated with an infinite sheaf cohomology superalgebra of observables. And using this terminology, one can associate the superalgebra and the filtration mechanism, which is very important for filtration of different levels of observation, with the internal observer applying abstract algebraic topology. And here you can also find some formal definition of the internal observer and how we associate the superalgebra of observables with that object. So when we look at the picture here, we can build a natural, actually, hierarchy of observers. So we can associate, when you look at the right bottom picture of a tetrahedron, we can associate some observables or some observer with an interior of that polyhedron. On the other side, going down, we can associate some observables with a face. And then going down, which is by means of the filtration mechanism, we can also associate some observables with the edges and then with the vertices. In this way, we can build a natural hierarchy of observers built on some kind of a network which is injected into the internal observer. And so the hierarchy of observers can be associated with elements of reality, a very well-known concept in quantum mechanics. It has with levels of reality. We have a natural nested structure of reality coming from these concepts, where internal observer actually is a kind of a totality of a system. And by means of the interactions at different levels, we can have occurrence of external observable reality. So on the left, we have depicted actually nth-level observer interacting with different levels of reality, or in terminology of physics, with different levels of the field. On the right, we can look at this abstract cohomological structure of the system. But on the other side, if we ask questions about the consciousness and mind, which is the subject of this symposium and is a subject of my upcoming paper about the insight and mind pioneering a new perspective on consciousness, we get to the conclusion that consciousness itself and mind is a nested structure interacting actually with the consciousness field, which I find very, very interesting and in some sense also revolutionary. So when we consider interactions among different observers, we have interactions actually on boundary at different levels, so that the interaction actually occurs on the boundaries. In this way, we also get to the concept of external observers interacting right on the boundary. And to ensure, that the information is consistent, we need to introduce a principle of the self-reconciliation of information among external observers, being actually inspired by the sheaf theory in mathematics. And here you can see actually just a very simple analog of three such nested cubes, which are connected and which share actually the elements of reality, so which share information. So you can see that the information is being shared at different levels of those objects. In this way, they generate actually reality at different levels. So again, coming back to the analogy about quantum mechanics, we could say that the most external is the classical reality, and then going deep dive, we get into the internal quantum, spatial reality, temporal, global, non-local, and so on and so forth. The principle is formalized as the self-reconciliation of information among external observers, just in terminology, as I mentioned, of these cohomologies and sheaf theory actually on graphs. So this is how it looks formally. And I also propose the principle for the self-consistency of an internal observer, assuming that an internal observer has to keep, in some sense, consistency independently of the external interactions. So the concept of the self-consistency, again, is motivated by the consistency of entangled histories, for instance, or a discussion around fibrated actually histories in space-time. And so we are getting to a concept of histories and time, which are fundamental for evolution of physical systems, and I believe also for consciousness and understanding of how consciousness occurs in reality, and how we process also consciousness and consciousness field. So the fundamental concepts are entangled histories. So you can take a look also at the papers. It's about quantum histories that can be intertwined due to quantum entanglement, leading to non-classical causal structure and leading also to entanglement in time. So quantum entanglement can manifest not only in space, but also in time. And the histories actually, which is very important, can also show and manifest the cyclic nature, where the end of such a history, so the end state, is connected to the beginning, representing an actual loop in quantum evolution, leading to some kind of a modular algebra, where time becomes modular. So I mentioned about the connections. I think that the concept will be fundamental of internal observer, and the hierarchy for external observers will be fundamental for evolution of our understanding of consciousness itself. So I believe also that there is a deep connection between quantum loops and cycles of consciousness at different levels. Quantum processes in brain might give rise to conscious experiences, as we know, and what is being also discussed in this symposium. But cyclic patterns also in quantum systems could mirror rhythmic patterns observed in conscious entities. This is why this looping or chaining and co-chaining in closed way is so fundamental. And as an implication, these loops of internal histories, which are related to cycles of consciousness in some sense, can provide a framework for understanding the quantum nature of consciousness. And it can also potentially bridge the gap between quantum physics and cognitive science. The observer, in some sense, can be understood or treated as a harvester. Again, coming back to the sheaf cohomology theory, we have actually bundles of stalks and we have a harvester. So the observer can be treated as a harvester, which collects data from the sheaf over each state that it is interested in. In some sense, when we look at the consciousness, we can say that we are also harvesting our experiences throughout our life. And this could correspond to performing a measurement naturally on a quantum system, but also classical, and corresponding also to recording the result. In the applications to future AI model, I assume that the sheaf represents the structure and local information of the system, and the recorded result or the harvested data directly influences the subsequent state of the system, but also the whole history before the point of harvesting data. So you can see that the concept of histories is naturally taken from our experience, but is also formally represented in quantum mechanics, but seems to be also fundamental for the future development of artificial intelligence systems. When we ask about future prospects of these concepts in physical information theory of the internal observer, we have three main areas. One is related to quantum gravity. There is a difficulty in developing a consistent theory of quantum gravity, and that could arise from a misunderstanding of the role of the observer in the quantum theory, which is central, as I mentioned. And a proper understanding of this internal observer perspective could lead us to new insights in the quantum gravity research. And naturally, the concepts that I showed are already being discussed in quantum gravity. Then, very fundamental for consciousness and self-aware AI or self-aware type of machines we can think about exploration into the quantum nature of artificial consciousness. And the model can actually pave the way for development of AI systems with a sense of self-awareness. And the question about when actually a machine can be treated as self-aware, because the tests that we have are insufficient in the context of this model, because they don't actually know about those different nested levels of reality. This also offers insights into how quantum processes might play a role in cognition for artificial entities. And finally, we could say that, as I mentioned, preparing the paper about the inside the mind, that we can expect a novel model of consciousness, broadening our current understanding of what consciousness is and what mind is, and how the interaction looks at different levels, including quantum. So we expect deepening the understanding of the role of quantum processes in human and animal consciousness. That's all from my side. Thank you for listening, also watching this talk. You are invited to contact me if you have any questions or comments. Thank you.